Pairs of angles. Our objective is to identify adjacent, vertical, complementary, and supplementary angles, as well as find measures of pairs of angles. Who uses this? Scientists use properties of angle pairs to design fiber optic cables. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. So, angle 1 and angle 2, they're right next to each other. They share a common side, but no common interior points. A linear pair of angles is a pair of adjacent angles whose non-common sides are opposite rays. So, a linear pair basically is a set of adjacent angles that make a line. Linear line. Let's look at an example. Tell whether the angles are only adjacent, adjacent and form a linear pair, or are not adjacent at all. Angle 1 and 2. 1 and 2? Well, they are only adjacent. They don't form a line. So, only adjacent. Try B and C on your own. Now that you've had a chance to try B and C on your own, let's try them together. So, angle 2 and angle 4. Angle 2 and angle 4. They are not adjacent at all, so there's no way they're adjacent and form a linear pair. So, not adjacent. Alright, angle 1 and 3. Alright, angle 1 and angle 3, they are adjacent and they make a line. So, they are adjacent and form a linear pair. Let's look at complementary and supplementary angles. Complementary angles are two angles whose measures have a sum of 90 degrees. Supplementary angles are two angles whose measure have a sum of 180 degrees. Let's try a couple of examples using complementary and supplementary. Find the measure of each of the following. The complement of angle M. So what that is asking is, what is the other angle that needs to, what's the other degree of the angle that needs to be there to make it so that the two together are complementary? They add up to 90. So 90 minus 26.8 will give us the complement of angle M, which is 63.2 degrees. This next one is a little bit trickier. The supplement of angle N, well, supplement, your supplementary angles, are 180 degrees, only this time you don't have a singular number or decimal. You've got a variable in here, an unknown. So that means in your answer you're going to have an unknown. There's no equation going on, it's just an expression. You can't solve an expression, you can simplify an expression. So just like we did here, 90 minus x, and x happened to be our 26.8. If we're doing supplement, it's going to be 180 minus x. Well, our x is this 2y plus 20, so we're going to substitute that in. So when we substitute, we end up with 180 minus 2y plus 20. We can simplify that, not solve for it. So we're going to combine like terms and distribute this negative, because this is saying minus this whole quantity. So it's like saying minus 2y minus 20. So we have 180 minus 2y minus 20. And then we can combine like terms. 180 and minus 20 give us 160. And you can't do anything with the negative 2y. So your answer is 160 minus 2y. Another angle pair relationship exists between two angles whose sides form two pairs of opposite rays. These are vertical angles. Vertical angles are two non-adjacent angles formed by the two intersecting lines. So we have two lines, they're intersecting at a point, and then the vertical angles are going to be the non-adjacent angles. So angle 1 and 3 and angle 2 and 4. Be careful though, because say I add an extra ray in here and call this 5. 5 and 3 are not vertical angles. They're not two lines that intersect. This is not a full line, it's just a ray. You need two lines that intersect. So after drawing in this 5, the only vertical angles would have been 2 and 4. What's really cool about vertical angles is they are always congruent. So angle 2 is congruent to angle 4. Let's look at an example. Name one pair of vertical angles. Do they appear to have the same measure? You can check by measuring with a protractor. Well, we have angle EDF is congruent to angle GDH. If you chose the other one, you might have had angle EDG is congruent to angle HDF. And that concludes our lesson on pairs of angles.